My name's Jason, and I'm going to be talking about automation today. Particularly, I'm going to be talking about that kind of automation that we all can't stand. Bots banging on websites, botters going out there and buying up all the PS5s, all of the different permutations of automated attacks that might be hitting some kind of web application. So who am I? Well, my name is Jason Kent. I've been, as I was introduced, I've been walking around for about 20 years looking at web applications and trying to figure out why problems exist. And so as I go along through this journey, I've been trying to bring my research forward for people to see it. And I try to give more and more people education around how they can also instrument themselves to do this kind of work. I work for a company called Sequence Security. They're the guys paying the bills these days. And my title for them is hacker in residence, but I do adversarial views into customer networks, and I do research, that kind of thing. So why do bots hit your website? I mean, this is one of these really curious questions, and it's really interesting. And the way I got my job here at Sequence is I worked for a consulting company. We did pen testing and app work. And we had all these visitors to our website. And what had happened was a company with a similar name to ours was really rude to their employees. And all these bots started bombing our website. And I instrumented ourselves with the Sequence solution. I looked at the bots and it got me very interested in, why are they here? So there's some reasons that bots show up, right? Sometimes it's just automatic hunting. And I'll dig into each one of these pieces, but sometimes it's just, we just point it at the internet and go, and you end up landing on something interesting. Additionally, there are directed attacks, obviously. I'm just going to go out there and try to get some information or get something off of a website or a mobile application fabric or whatever that might be. And I might want to try to do something very specific. There's a lot of sites that have financial benefits. And it's often been said that the reason you rob banks is because that's where the money is. Financial benefits often will drive someone to your website for automated attacks. We have a lot of customers that do things like credit cards and gift cards and that kind of stuff. And we see attacks against those platforms all the time. And then the last piece I'm going to cover in why is hot stock items, those PS5s, those really hard to get sneakers, those Supreme shirts, whatever that might be. So automatic hunting is something that a lot of us do. We go out and, you land on some domain and you immediately start pecking around at what are the other, subdomains that are available out here, or what are the pieces that I might find. And if I'm on www.example.com, I might look to see, is there api.example.com or api-dev or UAT or, some of those things. And so that automating that and finding out what those endpoints are takes a lot of that work away. And it's really simple to do a few lines of Python and you're out and doing whatever it is that you might need. Another automatic attack that you might see is a spec search. And I'm starting to see more and more of this in our customers. They're looking for API-docs. They're looking for swagger.json. They're looking for all of these things that are going to give them an API spec that's going to allow for them to dig into the site that you have set up and understand what are the security infrastructure pieces that are in place and where are you missing them. So if you want to look at an interesting project out there, it's a good Google search called Kite Runner. Kite Runner is an automated way to just do this. And it'll go out and go get you all the different permutations of possible spec that you might have in a public repository. And then the last automatic piece that I'm just going to talk about, and I see a lot of, is bug bounty searches. People looking for, oh, you left your WP-admin file out in the open. I can see administrators on it, give me $50. Same thing with XML-RPC.php on WordPress sites. I see this all the time. I've got a lot of customers that have built, fully deployed e-commerce platforms. They use WordPress as the way it gets deployed, and they're constantly being pinged for these kinds of things. Add to that wp.json, which is going to show you basically the spec for the site and the routes. And you've got a nice output that comes out of this automatic hunting. We can move from automatic into directed once we have a good understanding of these things, but oftentimes directed attacks are pointed directly at you for some reason, right? A lot of times it's account takeover. I just go see, I grab a credential dump that's out there and I go see how many of these credentials exist out on your site. How many of them are there? How many of them are available and respond to that credential dump? This is why enabling two-factor for your customers is really important, and it's a great way to do it. I know we all like to say, well, it's our customer's job to enable that stuff, but let me tell you, our customers are going to keep using 1, 2, 3, 4, 5 as their password, and I think it's really on us to make sure they're protected. But they're going after things like rewards programs, spending all your rewards points. I know if they got all my airline miles, I'd be pretty upset, right? We'll see account takeover for things like purchasing, where you've got a stored credit card in a platform. Let's pop out some, free whatever widgets that we can send to our house. Oftentimes, this stuff comes from credential stuffing, but that is a directed attack in and of itself. A lot of times, attacker platforms will go validate a whole bunch of a credential dump, and then once they have a good validation on that, they can come back and resell those credentials as validated and available. We also see directed attacks on things like purchasing all the inventory, right? Inventory takeover attacks. We also see things like seat spinning attacks. Seat spinning attacks are my favorite attacks to talk about because they deal with the most complicated thing I think that you could do, and that's you go figure out where you can get airline tickets. You take someone else's credit card and you put a hold on an airline ticket, and then you go sell that airline ticket on a black market site inexpensively. You get the revenue off that. The credit card holder has to fight through, and hopefully, the airline is going to honor all of this transaction as it goes. It's a crazy long attack to orchestrate, but we do see these kinds of things happen. But more likely, you're going to see inventory takeover attacks where they're just simply trying to lock the inventory up and either buy it all or make it so that it's a hard time for everybody else. Think PS5s. There's often financial benefits that go on with these kinds of attacks, and they're pointing at things like gift cards. I recently worked with a client that they had a gift card endpoint that was getting hit pretty constantly. And I looked and there was somebody just guessing gift card numbers. They would take those gift card numbers, they'd run them against the value checker. Once they had the good value, they understood that that was a good credit card good gift card. They would then take that gift card and either resell it out on the black market, or they would just go and use it for the services that they offered. Credit card attacks, I see a lot of organizations now moving toward we don't want anything to do with credit cards. We tokenize out at the edge. We don't want anything to do with this stuff. And I've seen attacks where they pre-guess the tokens and attempt to do checkouts. And sometimes it works. It's a really difficult attack to pull off. You got to have a lot of infrastructure in place. But if somebody wants money, oftentimes they'll put a lot of money into it. And then the final thing that we see a lot of, and that I deal with all the time, is rewards points. Either transferring them in and out of your account, so you lose all the rewards points off of your hotel or airlines or whatever, or rewards points that can be transferred for physical products. There's a lot of companies out there that sell, various products that if you buy enough of it, you get one free, and they're after that one free. Just another sort of understanding around hot stock items. I deal with these drops all the time. We've got several customers that do, things like sneakers and consoles, et cetera. And when we see these drops go out there, the reason that we see the drops causing so much problem is, kind of multiple fold, but oftentimes it's like poorly designed waiting rooms. The reason that you're being attacked or the why that you're being attacked in this hot stock item Is your waiting room is poorly designed in that first come, first serve, or the ability to get to a checkout first is what's going to get you there? And, do you know who can get out of line faster than any human? Computers, right? So if you're going to put me in a waiting room, I'm basically going to be starting my waiting room experience 100th in line, and the attackers are going to get out of there way before I am and buy up all the stuff. We also see hot stock items failing because of automation, just due to not understanding API channels versus web channels. A lot of times you can make a purchase with the mobile app much more easily than you can by going to their website. And the botters know this. And in fact, they almost always attack the API channels. Rarely do you see botters just going in through the front door on a website. It's extremely rare. Whoever can make the transaction the fastest wins. APIs are built for speed, so bots win. Just kind of as an aside on this, if you want to look at, how human controls enable bots, all you have to do is read this Tom's Guide article on his PS5 restock and how he beat the bots. And my only comment on this is, if you're rewatching this and you're slowing down and actually going to go read this article, is he only signed on 3 times. What he didn't realize is, using the same email address, using the same shipping address, you can make 100 accounts. And he could have been in line 100 times instead of just 3 times. And so that's something that, all of us that work in this industry and that are trying to prevent these kinds of things need to keep in mind. Plus signs and a Gmail address. If you head out to my company's website, sequence.ai, and go to our blog, you'll see a blog I wrote where I sat out in front of the police station in my local town, catching free Wi-Fi and making valid Gmail accounts that would go through reCAPTCHA 2 easily. So just having understanding that we can act like the bots and we can be a human in a bots world and still win is interesting, but it's even more interesting in the way that you have to make it work. So why is this automation working, right? They're coming after us for all these reasons, but why does it work? And realistically, I'm going to cover a couple of different aspects to this and things that you probably can go look at your applications, figure out how automation is working, and start to put mitigations in place for that. So errors enable behavior. You've probably seen, I don't know how many times, somebody throws a tick mark at a website and the tick mark dumps out a bad SQL message that gives up the whole store. That really doesn't work that much anymore, but the concepts still work. And those error messages were really important. And in fact, they taught us all to read error messages very carefully. One of the really important aspects of understanding your application is looking at how much data transfers back and forth. And if you have too much information in your API, then you're going to enable behaviors. Things like forgotten endpoints, really simple stuff, right? Very simple. I just forgot that one's out there. And I'm going to give you some examples that you can look for when you're looking at your own endpoints these days. And then I'm going to talk about user behavior, because in addition to the infrastructure that a bot attack is going to use, and in addition to the credential set and all that, what you're really going to notice in a bot attack is their behavior, how they behave. And having assumptions on user behavior is going to drive your application to function really in a certain way. So this is a little small on the screen, but basically I went to a website, I went to sign up. So I signed up for this service, and then I went back and I filled the form out again, having already had my email address in here. And you can see it says the email exists. So what does that tell an attacker? Well, this tells an attacker that I can do credential validation right here. I can go validate usernames very easily. And you can see that the round trip on this isn't very big because I haven't filled out anything else on this page. All I did was stop typing and it went and validated and gave me this. So once I figure out how to inject onto this endpoint, I don't even need the web page anymore. I can just set up burp or Zap, and I can go run against this thing with a giant list of usernames. So having this really simple thing of, well, that email already exists, makes it so that an attacker knows where the user accounts are for this thing. And if I've got a big credential dump that I'm doing validation on, I'll run through these first, then run through the passwords on them on the authentication screen. And then I have a valid credential set, or at least I have an understanding if it's valid or not. Once we move into actually interacting with the application, you're going to see that there's a lot of information that gets dumped out in API exchanges and in regular web traffic exchanges. And I'm going to go over a couple of different examples here. One of them in some recent research I did on a 2,000 customer platform that allows for you to join the community for one of these customers. But I can jump from community to community just by manipulating what it looks like a SQL statement. But if we look at what I'm getting at here, I have all of the routes that are available to things on the back end here. So now I can start with this list of what's back there. You know, a long time ago, when we first started looking at API security, our biggest problem was there's no hrefs, there's no internal thing that's going to tell me what is available. But now that I can find the routes that are available, or now that I can find different permutations of the things that are paths inside this application, it makes it really easy for me to run a scanner against this. And as an adversary, you probably don't want me running a scanner against this, but it's true. If we look at the example on the right, this is from some research I did with a company called ChowNow. If you were paying attention during the pandemic at all, you notice that all of a sudden you could order anything from everyone and they would bring it out to your car. ChowNow, Toast, all these point of sale organizations started layering in support for having a website, having a mobile app so that would make it easy to order. And if you go look at the communication that comes out of that stuff, it's got a lot of information in it. GPS coordinates to the place, its address, phone number, contact information. And ChowNow, it actually tells you what level they are with ChowNow, processor keys. There's all kinds of great information that's inside of this. I've disclosed this to ChowNow. They've told me that it's nothing that I need to be worried about. It's all public information. So here we are in the public having a chat about it. In addition to them, this organization, Lithium, I was testing a new tool that I'm going to talk about at the end of this talk. We were testing this new tool, and I noticed that when I logged into Fitbit's community, I got this really weird search query that came out. And you can see it's, this kind of odd alphanumeric string. And then it says select splat from, users where, blah, 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 right? I can take this information and start manipulating it. And if you actually look at the query as it appears on the screen in the upper left, this is just the query that occurs when you finish your authentication. I went ahead and said, well, instead of the profile ID that returns my information, I can just set that profile ID to 1, and maybe I can get the first user, which is typically the admin user. And then, of course, that worked. And I got a bunch of information back. So what I could do here is start to manipulate the query strings inside of this. And what I ended up doing was taking this query and looking at that really strange string that was at the front of the query, this one that's XM, NUZ, et cetera. And I thought, well, I wonder what that is. And so I looked at Lithium's DNS entries and recognized that this one was in there. And I surmised that, well, maybe this is how you get to this particular multi-tenanted platform's tenant. And I can do this select splat where ID equals 1, and I get the first admin. And then over here in this query, I set the profile ID to 1 for the admin's account, but I changed the query to a different community, and this is Roku's community. I used the same authentication that I had for Fitbit. It was exactly the same token structure. All I changed was this and the query, and I got back Fitbit's first user, which is also the admin user. I say this is too much information in your APIs, and I say that I don't think that it should work this way. And so I went through a 90-day responsible disclosure with these guys. It ended on the 22nd of August, so we're a month away from that. Just published a big blog post about it. So if anybody's worried that no one knows about this, they know about it. They sent me several emails telling me that this is not an authentication bypass and that that isn't a SQL statement and that everything's fine. So it's a great example to use because I can keep poking around on that thing and keep getting data. So in addition to the errors and a little bit too much information coming out, we're talking about forgotten endpoints, right? Iterate through your endpoints in your applications and your APIs that you have for mobile applications, and take a look and make sure that if version 2 comes out, don't leave version 1 on. Oftentimes when you reversion, you're increasing security or you're doing some kind of check to make things work. In addition to this, sometimes, these queries, they land on like v1/, but check it without the slash. We just recently had a customer that had big bot attack coming in because it was hitting an endpoint that was without the slash and they weren't paying attention to it. Look for obvious stuff, right? WP.json is a great one if you're using a WordPress site. P12 files. I mean, there's all kinds of different things that are out there that could be dangerous if somebody can read them. And this last little piece, I'll pause it for you to think about, and what's driving some of this automation is we have assumptions about how a user is going to work. So should one user come from 247 different IP addresses? Probably not, right? Should the user agent string for Chrome be found in your mobile app flow? My guess is no. And those are really simple things to identify. What's hitting the mobile app strings? Should everyone in the world be able to get to your site? I work with a lot of regional customers that they don't need everybody to get to their site. So one example of an attack that I saw just this week, this client IP address hitting all of these weird endpoints, using this weird user agent, a little client. If anybody knows what this is, hit me later on in the Slack and let me know. But this is 350 requests in 2 weeks. So this is dribbling in, right? But it's going to all these PHP endpoints that are possibly WordPress vulnerabilities. And it's just trickling in like that. This, if you look at it, is regional to China. So this customer doesn't operate in China. So there's no reason that they would be coming after them. This automation is hitting them, and I see it every night. Another example of this is I've got a customer where they're constantly getting these kinds of requests where it's going to order endpoints, looking for orders that may have been filled or may not have been filled. And this may not be sequential and it's not really all that obvious, but half of these requests, this is half of the requests that came in a 20-minute time span from 2 IPs. This is really strange, right? Oftentimes this is like a customer service center or something like that that's generating this kind of traffic, but that's not the case here because all of these, if you know the client and you go into everything, all of these orders were being shipped to places all over the world. There's no reason it should be coming from 2 different IP addresses if they're not customer service center, and it wasn't. So some cautions for you out there. I alluded to your spec documentation being available. I just went into Google and I typed in URL semicolon API-docs, and I got back 10 pages of stuff. But here's some interesting ones. GitHub for Amazon, if you're a selling partner, has all of their API documentation available to you, lets you know how to do it, everything you need to know. BigCommerce, what their API status codes look like, etc. There's lots of Swagger files that are available out there. So when you want to harden yourself a little bit to these automated attacks, something that you really want to look for now, especially, is do you have spec documentation available? Is it even available? And if it is, are you using it for your security products? You can instrument a lot of security products with spec documentation these days. Just don't put the documents in a public place, because attackers are grabbing them and they're doing what they want to with them. And it's becoming an interesting time for that spec documentation where we were all pushing for a few years ago. Go teach yourself. Take a look at the things that you have. Google for your docs. Look for your API documentation on your site. Site colon and your top level domain will lock down the Google search to just your TLD. Look for errors in your apps. The errors should not give me more information to make the attack work better. Run your mobile apps through a proxy. Are you pinning your certs? Are you doing the things that you should be just to make it harder for an attacker to look at this stuff? Look at your logs, unless you don't have logs, and then you should get logs. And you should have something to consume them and be able to search through these things. And the last thing, I'm going to give a little pitch to the OWASP Crappy project. I really love this project. If you're doing anything with APIs, running through the challenges on this is going to teach you quite a bit, and getting your developers to run through these is going to help them understand the things that they need to. Last piece here is be on the lookout. We're going to be launching a product that you'll be able to use for free that will go look for all of the endpoints that you might have hanging out there. And we're going to be putting in things like being able to find if you have spec documentation out in the public and that kind of stuff. So it's a discovery service. We're starting to bring it online now. We don't quite have it up and running. I really wanted it for today, but I got overruled by the CTO. So the stuff is going to be coming along shortly. So, stay tuned to our channel, and we'll definitely have this thing out in the next couple of weeks. If you're interested in following up with me or finding out more about the things that we do, you can find me on LinkedIn or shoot me a quick email at jason.ken@sequence.ai. Looks like I'm up on the end of my time. I'll be spending the next 30 minutes or so over on the Slack channel to answer any questions that you guys might have. Really appreciate OWASP having me out, and thanks for everything you guys do.